March 4th, 2011. You guys can consider this
last year?
no,
Or last
maybe lesson 2.4, something like that, okay? So if you have to make any extra notes, you can do it on 2.4. We'll put that up here just so we have a page to work with. We're going to be going over a lot of the concepts we've already learned and just how to apply them. Okay, so slope-intercept, slope y-intercept, y equals mx plus b. You guys already covered that in grade 9. M is equal to your slope, b is your y-intercept. You guys already need to be pretty strong with this, okay? Standard form. Standard form you guys covered in grade 9 too. All it is slope y-intercept form set equal to 0. So our red equation, slope y-intercept, were set equal to y. In standard form, we're set equal to 0, which means we've moved all the variables, all the numbers, all the constants to one side of the equation. So 0 represents nothing being left on the other side of the equation. And finally, today, they've given us a formula for point slope form. That is y subtract y1 equals m, which is the slope, multiplied by x subtract x1. So m is your slope. x1 and y1 are a point on the line. So you'd be using your third form. Maybe we should number these just so you guys have an idea. Our third form is used when we have the slope of a line and we have one point. Okay? We want to get to another point. We want to figure out another point along the line. Okay? So as long as we have one point and the slope, we can always get another point along the line. We can also use our slope y-intercept form to solve for the same stuff. We've done it before. It's just this one's a little more organized. Okay? So what we're going to do is we have an example on page 112 in your blue book. If you don't have a blue book, look off somebody's for now. Okay, guys? This is the first example they've given us. 2x plus 3y minus 6 is equal to 0. They say, example 1a says find the slope and the y-intercept of that line. So first of all, of the three forms I have above, what form is this one in? Somewhere. It's in standard form. So this one is set up with our ax plus by plus c equals 0. So in this case, our a is a 2, b is a 3, c is negative 6. Okay? Not entirely important, but just so we can tell how these two relate to each other. Now, we'll always be working with the equation of one line. We're not working with two different lines, three different lines. When we go from standard form to slope y-intercept form, it's still the same line. We're just reorganizing it, you could say. So, in our standard form, we're set equal to 0. To get to slope y-intercept form, we're going to need to set it equal to y. So we have to rearrange our equation that's now in standard form and set it equal to y. So let's rewrite it again. 2x plus 3y minus 6 equals 0. So I'm going to go through this quickly because this is technically a recap. We're going to be moving everything away from the y, let's say. So we'll keep the y, just the y. On this side of the equation, I'm going to move everything else. So first of all, this negative 6 is going to go to the other side. It's going to become 6, positive 6 on the other side. The entire 2x is going to go to the other side. So what that means is because I'm moving the entire 2x, it's going to become negative 2x. It was positive on the left side. It's going to be negative on the right side of the equation. And finally, to move the 3 away from our y, because that technically says 3 times y, we've got to divide everything by 3. So we divide each by 3. Y is equal to 2 minus 2 over 3x. I'm now in our slope y equals, what I'll do is just so it looks very similar to our theoretical model, I'm just going to move the negative 2 over 3 to be the first term, plus 2. These two are still the exact same equation. All I've done, like above, is just rearranged it to look in a certain way that we're used to looking at. So this is very similar to our y equals our m x plus b. If we look up, our m is negative 2 over 3, and our b is positive 2. So, in our standard form, we had very different numbers. Oh, it's too bad I can't get this all in one. In our standard form, we had very different numbers. Our a was 2, our b was 3, our c is negative 6. That's our standard form. We rearranged the same equation. It's not a different equation. And we put it in slope y-intercept form. I now know what my slope is. My slope is negative 2 over 3. And I know that my y-intercept is positive 2. So that already answers our example 1a. Find the slope y-intercept form of this line. So I've gone about doing this. I'm going to give you guys another one. I want you to practice it right now. I'll write it in red so that you know that it's in standard form to start. We're going to have 4x minus 3y plus 2 equals 0. Okay, so we'll call this example 1a. I want you guys to take 2 minutes now and just try to rearrange this so it's in slope y-intercept form, okay? Okay, so you guys had 2 minutes. So exact same idea as above. We want to set this equal to just y to be in slope y-intercept form. So what that means, let me do it in block. 4x minus 3y plus 2. I'm going to move 2 of these over in one step. The 2 and the 4x. So I'm now left with negative 3y is equal to negative 4x minus 2. I move 2 of the terms over in one step. And finally, I got to get rid of this negative 3. So I'm dividing by negative 3 each term. That becomes y is equal to, because both terms are negative, positive 4 over 3x. Because both terms are negative again, positive 2 over 3. This is actually, even though they're fractions, this is actually in our y equals mx plus b form. The slope is 4 over 3. Our y-intercept is 2 over 3. So a good way to do that, to figure out where that would be on a graph, is to actually turn that into a decimal. That's 0.666666. So it's about a little after 0.6. So it's lower than 1, but above 0. Okay? It's just in between there on the y-intercept, or the y-axis. So we found the slope and the y-intercept of our original line. So we're going to go back up to our original line. That was this one here. Okay, so that was our original line. We already found the slope, the y-intercept. On the previous page, we discovered that in slope y-intercept form, where do we have it now? We'll take all of this over. I'll erase some on the other side. That worked out. Okay, so when we rearranged it, this was our standard form. This was our slope intercept form, we'll call it. Now I need to go into my point slope form. Point slope form looked like this. Y subtract y1 equals mx subtract x1. So what that's asking us is we need a number for m. When we put it into slope y-intercept form, we actually solved for all the information we need for our point slope form, okay? We have our m, that's our slope, m equals negative 2 over 3. And I also already have a coordinate. Can anyone tell me what a coordinate would be here? Something.
2,
Yeah? How would you write that coordinate? Not 2, 0, 0, 2. Because this is our B, which is our Y-intercept. That's actually a coordinate on the line. Okay? It's not just an imaginary point on the Y-axis. It actually falls on the line we're drawing. So this is a coordinate. Our Y-intercept is always at X is 0. And then because it's 2, Y is 2. So our X and our Y. We can call this our X1 and our Y1 if we like. Okay? So we can put this into our slope-intercept form right now. I have enough information. I have an M, which is this value here. And I have an X1 and Y1, which is that value there. So we can plug those into our equation. So we're going to plug these in now. We have our Y, subtract. Our Y1 is 2. Our slope, negative 2 over 3. And 0, whoops, X subtract 0. Well, in this case, we can even simplify this one, okay? We got lucky. We can get rid of all these brackets here. This says Y subtract 2 is equal to negative 2 over 3. And in our brackets, X subtract 0 is just going to be X. So negative 2 over 3 times X is just going to be negative 2 over 3 X. Okay? So I simplified it a little. Normally in our point slope form, what they're going to do is they're going to give us a specific point. We can always solve for our Y-intercept. We can always solve for another point along this line. We'll still end up with the exact same equation. The equations will still be equal. So we now have our point slope, or point intercept. Okay? So, now that I have all that, finally, what I want you guys to do is I want you guys to do part D on page 112. It says to graph that line. You guys have a chart? I want you guys to try graphing it right now, okay? Okay, so part D was they just wanted you to be able to graph this. We're quickly going to graph this. The easiest way to graph something is in which form? Yeah, y equals mx plus b, so our slope y-intercept form. We'll take a quick look here. This is our y-intercept. And we know that if we go down 2 and over 3, 1, 2, so 1, 2, 1, 2, 3, that'll be a point. Or we could do the reverse. We could go up 2, 1, 2, and back 3, 1, 2, 3. We'll still be on the exact same line. Okay? No, that's not perfect. We've graphed our line now. We're on the exact same line. We've used our y-intercept. We used our slope. Went right through it. So this is everything we've covered.